Erector Spinae. The erector spinae, we have a lot to look at, and I'll try to cover it quickly to make this video short and just kind of hit the high points. But erector spinae means straight, so that's the erector part, and then of course spinae just means spine. So just by that alone, you can tell that these muscles, that their main job is to keep the spine straight and upright. You can find these muscles on the posterior side, and they're vertical strap-like muscles that are somewhat deep muscles. They're underneath like the trapezius, the splenius muscles, the rhomboids. So just by the name as well, you can tell they're closer to the spine, so they're deeper than those other muscles. The erector spinae is actually a collection of muscles though. So we have three primary categories or three classifications that we have within that erector spinae group. And that's the iliocostalis, the longissimus, and the spinalis. If you look at this picture, you can see that the spinalis is the most medial, the longissimus is the one that's in between, it's in the middle, and you have the iliocostalis, which is on the outside. It's the most lateral of the group. So altogether, this muscle group of the erector spinae actually creates the largest intrinsic back muscle group that we have. A couple other interesting things about it. They're also known as our anti-gravity muscles, mainly because without them keeping us upright, we would just fall forward due to gravity. A common misconception, though, that we'll see with the erector spinae is that each one of these muscle groups are not just one long muscle that spans the entirety of the spine. While they do span a huge area, these muscle groups, they're actually made up of like smaller muscle segments that continuously overlap through the vertebral column. So that's one reason, like that overlap and the fact that we have so many of these that span such a large area and they're so close to the spine. That's why these are really key in spinal stability. So before we move on to our origin and insertion, action, nerve, let's break down each group within the erector spinae. So you have the spinalis, which is again the most medial, and it's closest to the spine of the three, and it spans from the lumbar region to the cervical spine and skull. Then you have the longissimus, so it's the one that's in the middle of these three, and it spans from the sacrum to the skull. And it gets its name because it's actually the longest of the three as well. So the iliocostalis, it's the most lateral of the three, and it spans from the pelvis to the cervical spine. So while it's good to look at these with more detail and to break it down into the from a group to the individual, I do want us to take a look now at the erector spinae collectively. So when we look at origin, insertion, action, nerve, we're going to look at that collectively as a group. Looking at the origin insertion first, let's notice something that's interesting here. So the origin and the insertion are the same. So let me read through that and then I'll explain. So the origin and the insertion, we consider it to be the spinous processes, transverse processes, and posterior ribs from the occiput to the sacrum and the ilium. And the reason that we list these together is, again, we're looking at these as a collective group. And essentially, we just want to know that they spread from the very bottom of our spine all the way up to our skull. You know, we can break down each individual group, like the spinalis, longissimus, iliocostalis, and we can see that those origins and insertions are a little bit different. But if we look at them as a collective group, then this is what we would say for the erector spinae overall. Now, if we look at action, so bilaterally, they do extension of the neck and of the trunk. Unilaterally, so if only one side of the erector spinae contracts, then you're going to get neck and trunk lateral flexion to that same side. As far as the nerves, so it's innervated by the spinal nerves. So when you see spinal nerves and there's not really like a specific one, they're innervated by the segment they're closest to, is typically the case. So that's why we generalize and we say spinal nerves.